Hi viewers, welcome to Sai Praveen channel. Today in this video we are going to learn about the superposition theorem. Superposition theorem. What is the reason to do this superposition theorem? First, there are so many number of combination of circuit elements, so many combination of networks available we are using in electrical circuits. So the purpose of these theorems, here we are discussing about superposition theorem. Along with this, so many number of theorems are there. Thevenin's theorem, Norton's theorem, like that. So here in our syllabus, only the theorem what is included is superposition theorem. So the statement, coming to the statement of the superposition theorem. See, in a linear bilateral network containing two or more sources, the response at any element is equal to the algebraic sum of the responses at the same element while the individual sources are acting alone, while the remaining sources are said to be 0. Okay, this is the statement of the superposition theorem. Coming to this statement, here we are considering this circuit to explain this superposition theorem. So see here, two or more sources. By including this point, two or more sources. Two sources, maybe two or more sources, whatever it is. But here we are considering a circuit, a network with two sources. One is voltage source, another one is current source. Okay. So here there are how many loops present in this circuit? Two loops. Loop 1, this is loop 1, this is loop 2. Okay. So we are having two loops in this network. How many elements are there? Three resistive elements are there. R1, R2, R3. Okay. So with this now we are going to explain the superposition theorem. So this current is I1. The current flowing through this loop 1 is I1 and the current flowing through this loop 2 is I2. Is it right? So one voltage source and one current source. Okay. First, if you see the statement clearly, the statement clearly tells us a thing. What is that thing is? In a linear bilateral network containing two or more sources, the response at any element, first we have to find out the response at any element when the circuit or network containing all the sources. See, you can take any element, you just take R1, R2, R3, any element you take. You can take any element, it won't be a particular element, or you can take a particular element. Suppose I am going to taking here the element R3. So the response at R3. So what is the response at R3? So response means what? Coming to a resistor, the response is the current flowing through it. So I1 is coming here, I2 is coming like this. See, if you consider the direction of this, so I2 is coming like this. Okay. Or you can consider, I am considering a unidirectional current in both the loops. Whatever it is, no problem. If you take according to the direction of this current source, no problem. It should be in anti-clockwise direction. But I take the current direction in both the loops as clockwise direction. It's not a problem. Now, the current in loop 1 is from top to bottom and in loop 2 is from bottom to top. That is, both the currents are in opposite direction when considering the resistor element R3. See, it is R3. In this loop, current I1 is like this from top to bottom, I2 is like this. That means both currents are in opposite direction to each other. So what I am considering here is I dash is equals to I dash equal. That means the response across the element R3 is I dash. I dash when both sources are acting at a time. I dash equal to I1 minus I2. I1 minus I2. Okay. So we call it as I dash. You can directly write it as I dash. So the response at R3 element when both sources are active. Let it considered as case 1. Case 1. Okay. While coming to the case 2. Let us go to the remaining part of the statement. Any element is equal to the algebraic sum of the responses at the same element when individual sources are acting alone while the other sources are said to be 0. So while coming to the second part of this statement, we have to do two things. Two more cases are there when coming to this particular network. So we have to make only one source to be active and other source is 0. We have to do any of these things. Only we have to make only one source is active. So I am going to make the case 2 voltage source as active. So case 2 voltage source is active. So if voltage source is active, what happened? The current source has to become 0. When the current source is 0, voltage source, current source, if it is a table, so we have two things, voltage source and current source, short circuit, open circuit. Okay, we can write these two things here, short circuit and open circuit. So in short circuit, voltage source is high. In short circuit, if you want to make the voltage source to 0, then you are going to make short circuit. So in short circuit, voltage source is 0. In short circuit, current source is high. Okay. In open circuit, voltage source is high. In open circuit, current source is 0. This is the basic thing. You have to know this thing. Then only you can do this superposition theorem. Case 2, voltage source is active. So then what happened? The current Is has to be 0. Now let us draw the circuit. The circuit should be drawn like this: R1, R2, R3, Is equal to 0. That means open circuit. R1, R2, R3. Here we can't do any problem. We just explaining the method how we are going to solve the superposition theorem. In the next video, we are going to do the problem. Okay. So see here, voltage source is active. That means voltage source is active. So here the current is I1. But in this loop, what is the current? It is no. Because why? Because it is open circuit now. That's why no current is flowing through this loop. When the current is flowing in a circuit, the circuit should be closed path. But here there is no closed path. The current source is open circuited to make the current source 0. That's why there is no current flowing through this loop too. So we have only one loop, that is current to be I1. So the response at R3 is I1. That's it. Next case 3. Coming to case 3, current source is active. So here current source is active and voltage source is 0. Case 3, current source is active. Current source is active. Then the circuit will become, we have to make the voltage source to be 0, Vs equal to 0, short circuit, R1, R2, current source is active, R3, R1, R2, R3. So the loop currents are I1, I2. So to make this voltage source to 0, we are just what, see here, voltage source, when the voltage source is 0 in short circuit. So we just make the source to be short circuit, then the voltage source becomes 0. Here Is is inactive. Now what is the element? What is the current response through the element R3? So the response at R3 is I1 plus I1 minus I2, that is equals to I1 double dash. Sorry, I double dash. Let us assume these currents like this. So while voltage source is active, the current is I1 at R3. While current source is active, the response at R3, the current through the R3 resistor is I1 minus I2. Sorry, I2 minus I1. Why? Because we are considering this loop. Current direction is here. Okay. Now what happened? Now see. Finally, what is our statement? In a linear bilateral network containing two or more sources, the response at an element, any element, is equal to the algebraic sum of the responses at the same element when individual sources are acting alone while the other sources are said to be 0. So what is the current? This is the current when both sources are acting at a time. So we call it as I dash equal to, what is the current responses through the same element. So while considering the two sources are active, we are considering the response at this particular element R3. Here also we are taking the response at R3. What are the responses? When voltage source is active, I1 is the response. I1 plus, when current source is active, I double dash is the response. I double dash. And this condition equals, the theorem is to be proved. Very simple. Very simple, this statement and this theorem. Don't feel it is tough. It is very easy. The superposition theorem is very, very easy. You have to keep these two things in your mind. What are the two things? Very, very simple. This one. There are two or only two sources. One is voltage source, another one is current source. Either it is AC or DC, whatever the supply. You have two sources, voltage source, current source. You want to make this voltage source to be 0, then you can do short circuit. You want to make this current source to 0, then you can make open circuit. Very simple thing. To make these voltage sources to be 0, sources to be 0, this is the rule. If you want to make voltage source to be 0, then do short circuit. If you want to make current source to be 0, do open circuit at that branch only, source branches. Okay. And then first thing, you have to find out the response at any particular element when all the sources are active in the circuit like this. See, when these two sources are active, at that time we have to find the response through the element R3. First half completed. Second half, case 1 completed. This is for case 1. While coming to the case 2, only one source is to be active. Number of sources, if 10 sources are present, make all the 9 sources to be 0. Only one source is active and find the response at the same element. And then see case 3, make other source to be active and make this source to be 0. and the entire network only one source is active. Like that, number of sources are there, you can find out number of cases. Okay, and then finally, if you take the response when all the sources are active and make that response equal to sum of the individual sources response. So this is all about the superposition theorem. Okay. Thanks for watching. Thank you.